Hello everybody, it's Mr. Mulvihill here. Happy Friday. You got the duck. Here comes the weekend. You guys been doing great. Um, it's hard, but as you're saying, when the going gets tough, the tough gets going. So keep up the good work. We're gonna do some more exponents today. And what you're gonna do really is you're gonna get out your journal or something. There's not gonna be no printed notes. You're just gonna kind of copy down what I copied down, and we'll take it from there. So your bell ringer. The directions right here. I'm going to give you guys some questions to try. You're going to simplify that one. You're going to simplify this one. This one. So you can write all these down here. Try to get this Google Hangout to work, so maybe later in the day I'll get that going, see if you guys have any questions to do. You can ask me, or just to get together again. Won't be mandatory this week, might happen next week, but just stay tuned today. Alright, so go ahead, pause the video, give those a try. You're going to simplify, remember in the product and quotient rule from yesterday, and if not possible, just evaluate. Okay, here, so this one, number one, you should be able to use the product rule. You're going to add these exponents, so you'll get 2 to the 5th. Number two, you're going to use the quotient rule. You're going to subtract these exponents. So 6 minus 4 is 2, so it's going to be 4 squared. These right here, 2 to the 4th plus 2 squared, we can't use the product rule or the quotient rule because we're adding. So this is going to be 2 times 2 times 2 times 2 plus 2 times 2. You should ultimately end up getting 20 there. 10 squared minus 10 to the 1st. Again, you can't use any rules, so 10 squared is just 100. Minus 10 to the 1st. 10 to the 1st, you guys, is just 10. This right here and 10 are the same exact thing. They hold the same value. And of course, 100 minus 10 is 90. This one, 3 squared times 10 squared. The exponents are the same, but their bases are not the same. So we have to proceed as normal. That will be 900. 2 to the 5th times 2 cubed times 2 times 2. Well, we're going to use the product rule. And so we're going to add up these exponents. But what is this exponent right there? Well, if there's not a number, just like we do with coefficients with x, we know there's a 1 in front. So we also know there's a 1 right there. So that's going to come out to 2 to the 9th. This one, 10 squared over 2 squared, we can't use any rules there because the bases are different. So we're just going to have to proceed as normal. 10 squared means 10 times 10. 2 squared means 2 times 2. So this is 100 over 4, so it's 25. And this last one should be x to the 6th. You're going to add those exponents. They should be the same. Okay, these rules are very important. I hope you guys got those right. And because they're so important, we're going to do some more practice with this. If you were getting those right, good. If not, here's your second chance to try some more questions and see if you get them right. So let's write some of these down here. You got A is 5 to the 3rd times 5 to the 3rd. B is 2 to the 4th times 2 3rd all over 2. C is 10 squared over 10. So you guys are copying this down. Supposed to be nice out today. I hope that's the case in Westmount. We got opening day for fishing coming up soon. Things are looking good. Things are looking good here. Alright, so you're copying these down. Go ahead and give those a try. Your directions are the same. Simplify if possible. If not possible, just evaluate. So go ahead and try A, B, C, D, E, and F right there. Pause the video. Okay, so 5 to the 3rd times 5 to the 3rd, we can use the product rule there. So we're going to add these exponents. We're multiplying, same base. You can use the product rule, we get 5 to the 6th. This one here, we're going to kind of do two things at once. Let's first do the product rule. So we're going to do 4 plus 3 to do the product rule. That's 2 over 7. And we're still over 2. Now what's the exponent with the 2 if it's not there? It's a 1. So 2 to the 7 over 2 to the 1 is just going to be 2 to the 6 when you use the quotient rule. This one here, we kind of have like two separate quotient rules. So this is just going to be 10, because 2 minus 1 is 1, and we don't have to write it. Plus, same thing, 3 minus 2 is 1, so 10 plus 10, that'll be 20. There's two quotient rules here. There's the first quotient rule, there's the second quotient rule. Alright, this one here, this one's kind of crazy too. We'll just take it one step at a time here. So, we're going to add these exponents. That'll be 6 to the 7th over, add the bottom exponents because it's the product rule. 6 to the 4th, and then 6 to the 7th over 6 to the 4th will just be 6 to the 3rd power. Alright, E, 7 over 7. Don't forget, that just equals 1. You're dividing the same thing by itself. And then this one here, be careful, don't multiply the 5 and the 2. This is 10 to the 10 over 10 to the 7th. You want to add these exponents using the product rule. And then this, of course, will be 10 cubed, mathematically. All right, so I hope those went a little bit better. So that's kind of a review from yesterday, but it's okay if you're struggling with this. This is definitely new in more ways than one. So we'll keep on grinding here. We are going to learn a couple new things today. So if you have another colored pencil, you might want to write this down. Here is our first question of the day. It's this. Can we have an exponent of 0? Can we have an exponent of 0? For instance, 4 to the 0. Well, maybe there's some guesses on what you think it might be. I do want to show you something on how we can figure out what's this going to be. So we're going to say, let's explore. Let's explore here. Well, say we have 4 cubed over 4 squared. We know from the quotient rule that this will be 4 to the 3 minus 2, and then that will be 4 to the 1, which we know equals 4. Hopefully you guys agree with that. So your job is to think about this one, 4 squared over 4 squared. And you want to figure out what 4 to the 0 equals, starting from here. How do I do that? Well, I'll give you one hint. You know that 4 squared is 16. And see if you can find what 4 to the 0 will be based on that. I'll give you guys, so pause the video, see if you can figure it out. Alright, so this is a proof. Proofs are very hard, but I wanted to challenge you guys. So we know that 4 squared is 16 on the top and bottom. And look, what we learned from right here, this question, was if you divide the same thing by itself, you're going to get 1. Okay. Well, we still don't know what 4 to the 0 is. Or do we? Because this is the quotient rule. And that means you can subtract exponents. So we're going to have 4 to the 2 minus this one. So that's going to be 4 to the 0. There's our 4 to the 0. And if you look now, we've just made a connection. 1 on a long chain of equal signs. These all are equivalent. So 1 equals 4 to the 0. So we just figured out that yes, you can have an exponent at 0. And we can say anything to the 0 power is 1. So here's some practice questions for you. Say you have 5 to the 0. What does that equal? What does 1 to the 0 equal? And what does 315 over 7 to the 0 equal? So pause the video, try those out. Yeah, this really shouldn't be too long because you know that anything, including this number, 5, 1, including this number, anything that you raise to the 0 power must be 1. So all these answers are 1, as we proved from up in the Explore section. All right, so that's one thing we learned new. I am going to have you try a couple more challenging ones with this new rule here. So write these down, just like I'm writing on loose leaf, and try these questions out. All right, go ahead, pause the video and try those out. All right, well this one should be 1 plus whatever 3 squared is. That's 3 times 3, which is 9, plus 1. So this will equal 10. 5 to the 1 is just 5. 5 to the 0, anything to the 0 is 1, what we learned. And then 5 squared is 25. So this will all equal 31. And then this one right here, we got a couple ways you can go about it. We do have the product rule going on, so you could do 0 plus 3, and that's just 3 over 6 to the 1. And then use your quotient rule to get 6 squared, which is 36. Or you could say, hey, 6 to the 0 is really 1, so it's kind of like 1 times 6 to the cubed over 6 to the 1. And 1 times anything is itself, and you'll still end up getting to right there. Maybe you saw it like that. That way it works too. All right. So I know we're moving fast here. So take a second and digest what we just did. We did the bell ringer, did some complicated exponent stuff right here. Then we learned this rule number 1. Can we have an exponent of 0? And yes, we know that anything to the 0 will just be 1. Okay. So we're doing it. If this was class, we'd be at like 25 minutes into class. So we are going to learn one more rule here. This is rule number 2. So if you want to get out maybe another color, if you have it, if not, no biggie. This is question 2. All right, nice and big here. Number 2. So the first question was, can we have an exponent of 0? And the second question is, can we have negative exponents? Can we have negative exponents? For example, what does 2 to the negative 1 equal? What does 2 to the negative 1 equal? Now, there is an interesting proof that goes along with it. Basically, it's saying